Hello and welcome. If you are getting ready to absolutely smash your WAEC, NECO and JAMB Physics exams, then you are in exactly the right place. Today we are jumping headfirst into one of the most important, and if you ask me, one of the most interesting topics in your entire syllabus, light and optics. Trust me, if you can master this, you are taking a giant leap towards that excellent grade you want. So let me ask you a question. Think about a submarine's periscope, or a mirage shimmering on a hot Nigerian road, or even the very glasses that some of you are wearing right now. What on earth do they all have in common? Well, believe it or not, the answer is physics. Specifically, it's the principles of light and optics. See, these aren't just some boring ideas in a textbook. They explain the world all around us. And more importantly for you, this is a high-scoring topic. We're talking about 10 to 15% of your exam. So paying close attention today means more marks for you. It's as simple as that. And just to set your mind at ease, everything we're about to cover is pulled straight from your official syllabus. No guesswork, no going off topic. We're going to cover how light travels, what happens when it bounces off a mirror, how it bends when it goes through water or glass, the magic behind lenses, and even how we get beautiful rainbows. By the time we are done here, you'll be ready for any question they can possibly throw at you on these topics. All right, let's get started. First things first, we need to build a solid foundation. So in this first section, we're going to cover the absolute basics, how light behaves, and what happens when it reflects off a surface like a mirror. Okay, the first and most fundamental rule you need to know is this. Light travels in a straight line. That's it. This simple but super powerful principle has a fancy name. Rectilinear propagation. It's the whole reason shadows exist, and it's the simple idea that makes things like the pinhole camera work. And speaking of the pinhole camera, let's look at how to calculate its magnification. Magnification, which we call M, is just a way of saying how much bigger or smaller the image is compared to the actual object. And the formula is super straightforward. Just look at it. Magnification is image height divided by object height, which is also equal to image distance divided by object distance. This is a very simple ratio that your examiners love to test you on. Okay, let's put that formula to work with a typical exam question. So, an object is 5 centimeters tall, and it forms an image that is 2 centimeters tall on a screen 10 centimeters away. We need to find the object distance, which we call U. All we do is set up our formula. Image height over object height equals image distance over object distance. That gives us 2 over 5 equals 10 over U. You just cross multiply, which gives you 2U equals 50. A little bit of simple division and you get your answer. U equals 25 centimeters. See? Not so bad at all. Next up, reflection. When light hits a shiny surface like a mirror, it follows 2 very simple laws. The first one just says that the incoming ray, the outgoing ray, and the normal, that's just an imaginary line we draw at 90 degrees to the surface, all lie on the same flat surface. But the second law, this is the golden rule you'll use for your calculations. The angle of incidence, I, is always equal to the angle of reflection, R. Remember that. I equals R. Always. Now, when we talk about curved mirrors like the side mirror of a car, we use one single powerful formula. It's called the mirror formula. As you can see, it's 1 over F, the focal length, equals 1 over U, the object distance, plus 1 over V, the image distance. But listen to me very carefully. The key here, the part that separates the A students from everyone else, is the sign convention. Knowing whether F or V should be positive or negative tells you everything about the mirror and the image. Mastering these rules is absolutely crucial. Let's solve one right now. We have an object 30 centimeters from a concave mirror, which has a focal length of 20 centimeters. We need to find V, so we plug the numbers in. 1 over 20 equals 1 over 30 plus 1 over V. Now we just need to rearrange to find 1 over V. That gives us 1 over 20 minus 1 over 30. A little bit of fraction work. The common denominator is 60, and we get 1 over 60. So if 1 over V is 1 over 60, then V is plus 60 centimeters. And remember what I said about signs. That little plus sign tells us something very important. The image is real. See how it works? Great work so far, really. We've seen how light travels straight, and we've seen how it bounces. Now in section 2, let's look at what happens when light does something even cooler. When it bends. This whole idea is called refraction. And it's the secret to how lenses work. You've all seen this, right? You put a straw in a glass of water and it looks broken or bent. That, my friends, is refraction in action. It's just the bending of light when it goes from one thing, like air, into another, like water. So why does it bend? It's simple. Light changes speed. When it goes into something denser, it slows down and bends. When it comes out into something less dense, it speeds up and bends away. That's all it is. Now, the math that describes this bending is governed by a very famous law. It's called Snell's law. It simply states that n, which is the refractive index, basically a number that tells us how much a material can bend light, is equal to the sine of the angle of incidence divided by the sine of the angle of refraction. JAMB absolutely loves asking calculation questions with this formula, so please make sure you have this one locked down tight in your memory. Okay, now for something really interesting. Sometimes, when light tries to leave a dense material, it can't get out at all. It gets completely reflected back inside. We call this total internal reflection, or TIR for short. Now, for this to happen, two conditions must be met. They are not suggestions. First, the light has to be going from a denser material to a less dense one, like from glass into air. Second, the angle it hits the boundary with must be greater than a special angle called the critical angle. Please memorize these two conditions. They are a classic WAEC theory question. And now we move on to lenses. Take a good look at the formula on your screen. Does it look familiar? It should. It is identical to the mirror formula we just used. 1 over F equals 1 over U plus 1 over V. So if you know one, you already know the other. But, and this is a very big but, the sign conventions, the rules for when to use plus or minus are different. For example, a converging lens has a positive focal length, but a diverging lens has a negative one. Mastering these different signs is what will make you stand out. Let's tackle a lens problem together. An object is 20 centimeters away from a convex lens with a 10 centimeter focal length. Same formula. 1 over 10 equals 1 over 20 plus 1 over V. Let's rearrange to get 1 over V by itself. That gives us 1 over 10 minus 1 over 20. The common denominator is 20, so that becomes 2 minus 1 over 20, which is just 1 over 20. So V is plus 20 centimeters. And once again, that positive sign tells us we have a real image. You can do this. It's the same process every time. Fantastic. You've got the theory down. Now it's time to put it into practice, just like you will on exam day. In this section, we're going to solve real past questions from WAEC, from JAMB, and from NECO. Now, here's what I want you to do. For each question, I want you to hit the pause button and actually try to solve it yourself first. Then press play and we'll go through the solution together. Ready? Let's go. First up, we've got a theory question from WAEC. It's asking for the definition of critical angle, the two conditions for TIR, and 3 applications. Do you see? This is a direct test of the definitions we just covered. This is exactly why it's so important to memorize them precisely so you can get every single mark. Okay, here is how to write the perfect answer to get full marks. The critical angle is the angle of incidence in the denser medium for which the angle of refraction is 90 degrees. The two conditions: 1, light must travel from a denser to a less dense medium. 2, the angle of incidence must be greater than the critical angle. And for applications, you can list optical fibers, mirages, or the prisms inside periscopes. Boom! Clear, concise, and straight to the point. Okay, now for a JAMB question. This is a classic calculation problem that combines what we know about lenses with the human eye. So a patient can only see clearly up to 50 centimeters, but they want to read something at 25 centimeters. We need to find the power of the glasses they need. This is a two-step problem. First the lens formula, then the power formula. Alright, let's break this down carefully. The object they want to see is at 25 centimeters, so U equals 25. Now the lens needs to create an image at their near point, which is 50 centimeters. Because this image is on the same side as the object, it's a virtual image, which means V is negative 50 centimeters. That's the trick. Now we plug it in. 1 over F equals 1 over 25 plus 1 over negative 50.
But we're not done. To find power, the focal length must be in meters. 50 centimeters is 0.5 meters. Power is 1 over F. So 1 divided by 0.5 gives us our final answer plus 2 diopters. Okay, last one. This is a tricky question from NECO that really tests if you understand how plane mirrors work with distances. So a man is holding a mirror 0.25 meters in front of him, and he's using it to see a parade that is 6 meters behind him. The question is, how far does the image appear to be from the man himself? You've got to be really careful with adding the distances here. Here's the logical way to solve it, step by step. First, let's find the total distance from the object, the parade, to the mirror. It's the 6 meters behind the man plus the 0.25 meters between the man and the mirror. That gives us 6.25 meters. Now we know that for a plane mirror, the image distance is always equal to the object distance. So the image is formed 6.25 meters behind the mirror. But the question asks for the distance from the man to the image. So we have to add the distance from the man to the mirror, which is 0.25, plus the distance from the mirror to the image, which is 6.25. Add them together and you get your answer, 6.50 meters. You've done an excellent job getting through that. Now, to make sure all this information sticks in your brain, let's wrap everything up with a final cheat sheet. Think of this as your last-minute revision guide before you walk into that exam hall. Here they are, the essential non-negotiable formulas you have to know for your exam. The mirror and lens formula, Snell's law, the critical angle relationship, and the power of a lens formula. And please, remember the two biggest warnings. For the mirror and lens formula, sign convention is everything. And for calculating power, never ever forget to convert your focal length to meters. Go on, take out your phone and take a screenshot of this slide. It's your exam cheat sheet. And finally, here are my top 5 tips for success in optics. 1. Always try to draw a quick rough ray diagram. It really helps you see what's going on. 2. I'm going to say it one last time. Master your sign conventions. 3. Always watch your units, especially converting centimeters to meters for power. 4. For the theory questions, memorize your definitions precisely. And 5. Practice, practice, and then practice some more past questions. And that is a wrap on light and optics. I really want you to walk away from this feeling confident. This is a very predictable topic. The questions don't change much from year to year. Once you master these core principles, the formulas, and the definitions we covered today, you are seriously on your way to an excellent grade in physics. You have absolutely got this. Now, if you found this lesson helpful, please do me a huge favor. Like this video, share it with your classmates and friends who are also preparing for WAEC, NECO, and JAMB, and subscribe to our YouTube channel right now so you don't miss the next topic. Also, be sure to visit ExamKP.com for thousands of free practice questions and answers. Let's smash these exams together.